Alright, we're on 1-6, translating problems into equations. Now, 1-5, we translated sentences into equations, and we've translated words into symbols. So we're kind of getting one step further, and we're actually going to be having some more, we're going to have some problems that we need to write into equations. Now, it's going to seem like you want to have to solve it, which eventually we'll get to, but right now we're just worrying about translating. So being able to start from words and get it into mathematical equations. So here are some steps we're going to take. So steps to translating problems into equations. Step 1. Read the problem carefully. And when you read it, think to yourself, what is known, which are like our facts, and what is unknown. So you're going to have to differentiate between the two because that's going to help you in setting up your equations. So read the problem, figure out what is known and what is unknown. Then we're going to choose a variable and represent the unknown. So in this case, we're going to typically have one unknown, but you could have more unknowns, okay? So choose a variable for one unknown. So you're defining the variable. It's very important that you let us know what you're using. If I'm using X to define boys, let me know that. B to define boys, whatever the case is, you need to know. Now represent other unknowns with variables when necessary. Depends on the situation. And lastly, reread the problem and write an equation. And so you're going to be writing the equation with the info you have written down as well as your represented unknowns. So again, basic premise. Read the problem and you need to figure out what's known and what's unknown. Choose a variable and you're going to be defining the variables. Then you're going to reread the problem and actually write the equation. So, first I'm going to read the problem. It says, first the instructions. Translate the problem into an equation. Got it. Okay, we're not answering the question even though there's a question. Not doing it. Okay. So it says, Miles has twice as many pens as Jackson. Together, they have 36 pens. How many pens does each have? So we need to know our unknowns and knowns. So I'm going to put first unknowns. So our unknowns are Miles' pens, like how many does he have? And we also don't know how many Jackson has. So Jackson's pens. So we're trying to figure out how many each of them have. What we do know, so known, we do know the total is 36 pens. So together they have that. So we have our unknowns and we have our knowns. So that was the first one if you look there. Now if you go back, it says choose a variable and represent the unknown. So again, there can be different things depending on what you decide to define. If you want to define Miles's pens as, the variable, or Jackson's pens as a variable, I always like to look at the problem and see which one will make my life easier. Okay, like using multiplication and addition versus subtraction and division. So let's see. It says Miles has twice as many pens as Jackson. So I'm going to put Jackson's pen equals J. Only because I know that Miles has more. So if I do it, I know twice means 2 times. So I know I can do 2 times Jackson's. So that would be 2J. Technically, you could still do, Miles, and you could have that, you could have done that, but then you would have had to use division to get back down to Jackson's, and I prefer not to use that. So, now we need to actually write an equation. So we know that Miles has twice as many pens as Jackson. Together they have 36, but how many does each have? Well, I know that however many pens that Miles has, which is 2J, plus however many pens Jackson has, which is J, will equal the total of 36 pens, which is what we had. And that's all we have to do. You might be able to simplify it, make it whatever, solve it. that's not what we're doing. We're just setting it up. So there you have that. We're gonna do the next one. Okay. Again, the first part is to read the problem. A 60-inch piece of string is cut into 2 pieces. One is 4 inches longer than the other. What are the lengths of the pieces? Okay, I'm just going to draw it out because I'm a visual person, so I'm going to say that, and then I'm going to say that's 60, and we're going to cut, and it's going to not, one's going to be 4 inches longer than the other. So we have this one piece, and we have this piece, okay? And one is 4 inches longer than the other. So, if we think of, okay, so we'll say piece 1, okay, and this is piece 2. Alright. So, now we know that if we were to start with the smaller one, right, if we were to say x is the smaller one, then we know that the piece 1 is bigger. You can see how it's a little bigger. So that means we have to add how much to the smaller one to get to the bigger one. The bigger one is 4 inches longer, so that means we have to do x plus 4. Now, could you have said piece 1 is x and then subtract it 4? Yes, you can, but I like to use addition and multiplication because they're easier to work with. So I know that if I add what piece 2 is plus what piece 1 is, it's going to be a total of 60. So I can say x plus 4 equals 60. Again, we're just leaving it like that. We're not simplifying anymore because we're not solving. We're just setting up. There you go.